Okay, you guys, so I'm going to be going ahead and I'm going to be reviewing how to solve some of these stoichiometry problems with you guys. I want to go over this problem-solving map. So you guys have already seen this before. This is basically a map to kind of guide you guys on what to do step by step for some of these problems. So what you guys will see on here is that this map goes ahead and tells us what conversions to do. So just to point out a few things, so you guys will see moles of A and moles of B. This can be anything. So this is just like any molecule that they give you in the problem. So this can be whatever molecule that they give you. So they usually give you two molecules in these types of problems. So this is just A and B just symbolizes different molecules, right? So this is going to go ahead and this is our starting point. And what we're going to do is that with this map, we can go ahead and we can travel through it and we can figure out, okay, what steps do I need to take in order to go ahead and to solve these problems. But before I do that, I want to kind of clarify some of the conversions that you guys are going to need to go ahead and to solve these problems. So I'm going to go over each of the types of conversions. Then I will go ahead and we'll have a separate video that will go ahead and go through some of these practice problems that reference some of these conversions. Okay. So our first and foremost, our most common conversion, we have grams to moles, right? So if you want to go ahead and if you want to solve for moles, right, you have to remember that your mole conversion is going to be on the top and your grams of whatever is going to be at the bottom. So it'll be moles of A and grams of A, right? So that is what you guys would be using, right? If you want to go, so that is for if you guys want to go this way. If you guys want to go this way, right, you guys are going to have grams at the top because you want to end up in grams, and then you're going to have moles at the bottom, right? So that is going to be one of your conversions. Another conversion that you guys have that you guys will see commonly is particles. So you guys have particles on here. So if you guys are going to go ahead and if you guys are going to go from particles to moles, right, you guys are going to end up with moles at the top. And there is 6.02 times 10 to the 23rd particles in 1 mole, right? You guys can also go the other way, right? So if you guys wanted to end up with particles, right, the thing that you guys would end up on here, and let me go ahead and let me modify where this arrow is being drawn so I have some room to write. You're going to have 6.02 times 10 to the 23rd over, right, a mole. And that's what you guys would have if you guys were going to go down from moles down to particles. But if you're going from particles to moles, you guys are going to use this conversion right here. Another conversion that you guys can use is going to be volume of a gas. But that's at STP, which is standard temperature and pressure, which is 0 degrees Celsius and 1 atmosphere. So that is what you guys are going to see. This one's not too common, but I am going to spend a moment pointing it out just in case you guys get any of these problems so that you guys are prepared. So if you guys are going to go from volume to moles, right? So if you guys are going to go this way, you guys are going to want moles at the top, right? And 22.4 liters at the bottom, right? Because we're trying to get rid of that. If you guys are going from moles to liters, right? You want 22.4 liters at the top, and then you guys want moles at the bottom. Okay, so those are your basic ways to go ahead and to kind of like travel through that side of the chart. And then that kind of gets you to go ahead and to kind of realize that, okay, these are the different types of conversions that I can make, right? And it's going to be the exact same thing on the other side. So I'm just going to go ahead and I'm just going to write them in quickly so that we have them when we're going ahead and when we're talking about some of these problems. Right, so again, moles over grams, and then if you're going to this way, you want grams over moles. Same deal on here, right? If you want to go ahead and if you want to get from moles to particles, right? You want 6.02 times 10 to the 23rd on top, and then you want moles at the bottom. If you're going this way, you want 6.0, no, whoopsies. You want moles at the top, and then you want 6.02 times 10 to the 23rd at the bottom. Same deal if you guys are going to go ahead and if you guys are going from liters to moles, you want moles at the top and then 22.4 liters at the bottom. If you guys are going from moles to liters, right, you want your liters on the top and you want your moles at the bottom. So those are the things that you guys are looking for. And it's the exact same conversions, right? The thing that connects, right, one type of mole to another type of mole is going to be the mole ratio, right? So this like big old arrow right in here, right? This stands for the mole ratio. And this is a step that I see a lot of students that are skipping currently, which is why I want to go ahead and if I want to address this. So if you're going to go ahead and if you're going to go from moles of A to moles of B, you guys have to use this mole ratio. And basically, you will get your moles of B, which is the thing that you guys want. And then you will go have moles of A at the bottom. And that's if you're going this way. If for some reason you're looking at the map and you're going this way, right, then you want your moles of A at the top, right, and your moles of B at the bottom. Okay. The other thing to note about this mole ratio is that in the mole ratio, you guys are going to have a number that's going to go right in this square, right? And this number, right, this number that goes in front of that is going to come from a balanced equation. So those are going to come from a balanced equation. So I will look at a balanced equation and I am going to go ahead and if I'm going to look at what numbers I have in front of the molecule that I'm talking about. So for example, if I had two CO2s, right, I would take this 2 and I would put it like in one of those boxes, depending on if it was my A or if it was my B. If I had like 3 O2s, right, I would take this 3 and I would go ahead and I would put that right in that box. So it really depends on my balanced equation, but I'm basically looking at the number in front of that molecule to go ahead and to kind of fill in that mole ratio. So how do you use this chart? So now that I've written down all of these conversions, right, it's super important that you guys know how to go ahead and how to use like a resource like this in order to make sure that you do all of the steps, right? So some people can kind of see like what they need to do like through the different conversions, and that's fine. And if you don't see it right away, this is kind of like a method to go ahead and to kind of help you find everything. So the most common path that is taken is that you usually start with some sort of mass in grams and you need to get to another mass in grams, right? So it will be a mass in grams of A right here, and then you need to end up with mass of grams in B, right? And so there's a series of steps that you have to follow, right? So what will happen is that you first kind of go up in here and you end up in moles of A. So you first have to do that mole to gram conversion. So that would be like your first conversion that you guys would have to do. Right after that, you guys are going to go ahead and you guys are going to go through this and you guys will end up with your mole ratio. So then you guys will have to go ahead and you have to look at your balance equation and figure out what's going to go here, what's going to go there, right? So that I can go ahead and I can get my moles of A to my moles of B. Then, last but not least, I would set one more conversion so I can finally get my mass in grams, right? And then in this one, you guys will see that you guys are using your gram to mole conversion. So that is going to be the things that you guys will do. And this is like the most common path. And usually if you're going to go from like one of these like things to like one of these guys on the other side, right? It's going to be about 3 conversions that you guys have to go ahead and that you have to go through in order to go ahead and to transfer some of these deals. Okay, so the highlighted one is your most common path. So another example could be that if they give you a volume, right, to go ahead and to start with, right? So say if we start with volume, and then they ask me, okay, so if I start with volume, right, how many particles am I going to end up with? And it's a different molecule, right? So then I would go ahead and I would go down here. And I see that in order to go ahead and to do that, right, I'm going to have to use this conversion. So moles over 22.4 liters. Then again, I would have to use my mole ratio, and I'm always using my mole ratio to switch from one type of molecule to another type of molecule. And then I would take these moles and then I would go ahead and I would make these into particles using that Avogadro's number. Right. So this is like a method to go ahead and to figure out what you guys need to go ahead and to solve. Right. And it's the same deal and you can kind of mix it around, right, and all of that. But mainly do not forget that some of these problems, especially when you go from grams of one thing to grams of another thing, or if you start with one type of molecule and you have to end with another type of molecule, that should be a big indication that your problem is probably going to include a mole ratio and it also has multiple steps. Okay, so I hope this map helps, and then we will talk about some example problems in the next video.